This example is similar to the bonus question that you'll have on the paper portion of the test. So you'll have some sort of question where you're finding different information, finding a z-score, or you're finding probability, but you'll be given that it's normally distributed, and you'll be given the mean and the standard deviation. And then you're going to use those to answer these bonus questions. And hopefully these will be freebies, at least two of them. Mean of 506 and a standard deviation of 118. Those should be, everybody, hopefully, will get those two right. Remember that when we have a normal distribution, so normal means it's symmetric, which means that the mean is equal to the median, which is equal to the mode. Now, I'm only asking you for the median, but it'll be the same as the mean. If we know the standard deviation, then the variance is equal to the standard deviation squared. So 118 squared. I think this is actually, let's say 11.8. So I think there's another example where I use these same numbers, but it's a decimal instead of a 118. So let's fix that before we actually calculate. And so if I do 11.8 squared, or 11.8 times 11.8, I get 139.24. Now, for my quartiles and my interquartile range, well, interquartile range is going to be, actually, let me do this in a different color. So the interquartile range is going to be Q3 minus Q1, and the range is going to be the max minus the min. But we have to find the quartiles and the min and max, and that's where our normal calculator comes in. So again, we know it's a normal distribution. We're told that it's normal, and so that means we should be able, let me see here if I can get the StatCrunch showing up. There we go. So I want to go to Stat, Calculators, and I want to use this normal calculator. And this is kind of squished a bit, but let's see, we can probably do that since we just need to see this box. All right, so we're going to put in the mean. That's going to be 506. And then the standard deviation is 11.8. And remember, when we are working with these, the quartiles, I can do one of two things. I can say, that would mean quartiles break our data into quarters. And so we would have Q1, the median, and then Q3. Median, of course, is also Q2. It's also the mean. But if I'm going to break these into quarters, then each one of these is 0.25. And I don't know if I've actually drawn them in the right spot or not. Oop. There we go. As far as the lines. But it's going to break it into even areas. And so I could consider this being everything that is, less than or equal to the first quartile would be the 0.25. So I actually know the area over here. And let's see, I need my keyboard. Show keyboard. So I'm going to ignore that 0. I could delete it, but I also it'll replace it as soon as I start typing or take it away. So I want to do 0.25. Oh, hold on, I don't think I got the decimal in there. There we go. 25. When I compute, that's going to give me that Q1 is 498. Let's see, I said round to the nearest 10th. I don't know why I have year here, which actually means then that would actually just be 139.2 because 4 would not round up. But our first quartile would be 498.0. So I could do this same thing and either change this number to 0.75 or change my symbol and my number, but I can also use the between. And so if I switch to between and I say I want to find the middle 50%, so that would be both of these together would be 0.5 or 50% of the area. And so if I put 0.5 with the same mean and same standard deviation, then notice I still get 498.041, which is what I had for Q1, but I also get the Q3 at the same time. And that one, again, we would round to the nearest 10th, would actually take that up to 514.0. So I'm going to put both of those into my table up here, 498.0, 514.0. If I subtract those, so 514 minus 498, that's going to be 16. So that would be my interquartile range. And then for this last row, remember, this is the minimum and maximum and the range in quotation marks based on the min and max usual values. So remember that the min and max usual values are the numbers with the middle 95%. So I can come over here again to StatCrunch, and instead of saying 0.5, I say 0.95. When I click compute, I get my min and max. So 482. That would round up to a 9. And then 529.1. And then when I subtract those two, so 529.1 minus 482.9, I get 46.2. So that is how you can complete that bonus problem. You'll be given these two, and then the rest you can calculate either just knowing that they're the same, knowing that you're going to square the standard deviation, or you're going to use the normal calculator to get these so that you can then use the formulas to get these last two.